Today we are going to discuss minimum added distance algorithm. This algorithm computes the cost of conversion from source string to a destination string, and the cost here may be the cost of deletion or insertion or substitution, and usually we suppose that the cost of deletion is 1 and cost of insertion is 1 and cost of substitution is 2, because in substitution we first delete the character and then we insert the character. So here the cost of substitution or place is 2. So let's start doing the example to understand the concept. Let me delete these values. So here is a table and this is the source word Dean, and we want to convert this word to the destination word donut, and here the character hash means nothing or empty string. So let's fill this column one by one. Here this cell means the cost of conversion of empty string to empty string, so definitely the cost will be 0. And here it means the cost of conversion of letter D to empty string, so we will delete one character, it will be 1 deletion cost. And here we are going to convert DE into empty string, so the cost will be 2. I mean we will delete 2 characters, so similarly 3 here and 4 here. And now let's fill up this row. Here we mean to say that we will convert nothing or empty string to the character D, so we will insert one character and the character of insertion is 1, so I will insert 1. And here we mean conversion of empty string to the word do, so the cost will be equal to the inserting of 2 characters T and O, so here we will insert 2, so 3, 4 and 5. So we will fill this first column and this first row this way, and now we are going to fill this column. Before filling this column, let's define the rules of filling each cell. And the rule is, if the source character like here D and the destination character like here D are the same, we will just copy the value from the diagonal. So here the value in the diagonal is 0, so we'll copy it from here to here, so we will put 0 here. Otherwise, here the source is E and the destination is D, the characters are different, we will compute the value from either this cell or this cell or this cell. If we want to compute the value from this cell, we will add 1 to it, so it will become 2 plus 1 3. And computing the value from this cell means we are actually inserting, and computing the value from this diagonal cell means substitution or replace. So as the cost of substitute is 2, so we will add 2 in this cell, so it will become 1 plus 2 3. And if we compute the value from this lower cell, it means a deletion, and the cost of deletion is 1, so again here we will add 1 to 0, so it will become 1. And so we get these 3 values, this one from this cell, the second 3 from the diagonal, and this one from the lower cell. And we will choose the smallest value of these 3 values. The smallest value here is 1, so we will choose this one. Similarly here we compute value from this cell, it will be 4, and from this cell it will again be 4, from this cell it will be 2, so we will choose a minimum value that is 2. And similarly here the minimum value will be 3. So in the same way we will compute all these cells and we will get the table like this. So here this 4 means the cost of converging the word Dean to the word Dono till here, and the 5 means the cost of converting the word Dean to donut. So the cost of conversion, the editing cost of conversion from Dean to donut is 5, and that is the minimum possible cost. And now the next thing is alignment. Alignment means how we will and in what order we will convert the source word to the destination word. So for the alignment, we will trace the path from this corner to this corner, and we will see we will draw all the legal arrows that and then we will choose any of the valid path. So let's start from here. Let us see how did we compute this 5, and the 5 was computed from this 4. So we put an arrow from 5 to 4, and this 4 was computed from 3. So we put an arrow from 4 to 3, and this 3 was computed from this diagonal value because here n and here n, they are the same. So we just simply copied this value to this cell, and this 3 may be derived from left cell, from diagonal, and from lower cell. So we will all these 3 paths are valid paths, so we may draw the arrows to all these 3 cells, and now it's our choice from where we continue. We can continue from this cell or this cell or this cell. So if we continue from this cell, this 2 was derived from the lower cell to 1, and this 1 was derived from this lower cell, and this 0 was derived from this cell, as the D and the D were the same. So we simply copy the value from the diagonal cell. So here we drew a path from this corner to this corner, and now we can choose any valid path, and all these valid paths will have the same cost, that will be the 5. So let's choose one of the path. We say we go from this 0 to 0, and as the value is same, so it is actually we are not doing anything, any operation, deletion, insertion, or substitution. So I put hash for no operation, and from this 0 we move forward. So as you know, move upward, and as you know, moving upward means deletion. So I write here D. I write here D, and from this one we move upward, and again it is a delete operation. I here D, like right here D. From this 2 we move to the value 3, and this parallel movement means insertion. So I write I, and from this 3 we move diagonal, and we have the same value. So it is actually here and is same here. So actually it is the no change. So I write here dash, and from this 3 we move towards 4, that is again insertion, and 4 to 5 again insertion. So let us follow this alignment in converting the source word to the destination word. So the first operation is no change. I write the word Dean. So the first operation will be no change, so we keep the character D. Next operation is delete, so I deleted the character E, and again the next operation is delete. So again I delete the character A, and the next operation is insertion, so I insert the character O, and then again it is no change, so we keep the character N, and again insertion, so I insert U, and then I insert D. So the word Dean was converted to the word donut. And now let's change and take another path. If we move from here, this corner 0 to 0, and it is no change, and then from this 0 we move to this 1, and that's actually deletion, and this 1, and from this 1 instead of going upward we move diagonally to 3. So it is a diagonal movement, and here the value 2 was added in this value to get 3. So it is actually replace a substitute. So I write here S, and from this 3 it is again the diagonal movement, but the value is same, so no change, and from here it's the same insertion and insertion. So I iterate the word Dean, and we will convert Dean to the destination word. The first operation is no change, so D was kept as it is. The next operation is deletion, so I deleted the character E. Next is S, that is substitute, so I substituted the letter A with O. And the next is no change, so we keep the letter N as it is. And the next is insertion, so we insert the letter U and then we insert the letter T. So these are just two alignments, and there are also other alignments we can move from this to, and so we may get many other paths, but all the valid paths will give us the same cost, that is 5. And that's it. Subscribe my channel for further lectures. Thanks.